Hello everybody and welcome back. We're on question number 6 now on our 2019 Euclid paper. So we still have a light bulb and a written. I think that's it, or is the... Yeah, it's writtens from here on out. Okay, so let's take a moment to enjoy our last light bulb question. A regular pentagon covers part of another regular polygon as shown. This regular polygon has n sides, 5 of which are completely or partially visible. Okay. In the diagram, the sum of the measures of the angles A and B is 88. Determine the value of n. Okay. What can we do here? So it's really going to be sort of all about angles. Now, how can we recognize a regular polygon's number of sides working with angles? Okay, so there's a couple things we should know. So to take any shape like a triangle, and you can, there's sort of a, no matter how weird the triangle is shaped, it's always 180 degrees is the sum of the interior angles. Okay? So take something like a square, or really any sort of quadrilateral, anything with 4 sides, you'll get 360 degrees. Same with pentagons. Okay? Some of the interior angles will always be 450 degrees. And if you're not seeing how we're getting these numbers, you go up by 180 each time. Because to make a pentagon, you basically just add a triangle onto a quadrilateral. Okay? And so triangle, interior angles there is 180, so we basically just add on 180 each time. Okay, now for a regular, so all the angles are the same, all the side lengths are the same. What's the sort of interior angle? Well, for a triangle, you would take the 180 degrees and divide by 3. And for 360 degrees, you'd divide by 4. And so, the equilateral triangle, interior angle is always 60 degrees, square 90 degrees. For a regular pentagon, like the one we have in the question, 500 divided by 5 is 100, 40 divided by 5 is 8, 108 degrees. So if we go to our little sort of picture here, and we imagine that we drew a regular pentagon, and then what have we got? We've got some sides here. So 1, 2, 3, 4, 5. B down here, A up here. Got 108 here. Okay. Now, if I look at 1, 2, 3, 4, 5, 6, I've got a 7-sided sort of little red Pac-Man shape. So it's a regular, heptagon. And so what's the sum of the interior angles going to be there? So 450, then we add on another 180. We'll get 720, add on another 180. We should get 900 degrees. Okay? So A plus B plus, what's this angle here? I'm going to call it, C. 1, 2, 3. So there are 4 C's. A plus B plus 4C plus, and then what's this angle over here on the other side? Well, it's got to add up with 108 to a full 360 degrees. So it's going to be 252 degrees. And all that needs to add up to 900 because these are the interior angles of this 7-sided shape. Okay, now they tell us A plus B is 88. Okay, along with the 252, the 8 makes it 260, and then the 80 bumps that up to 340. Okay, so subtract 340 from both sides, we'll get 4C is 900 minus 300 is 600, minus another 40 is 460. Divide by 4 on both sides, we'll get 140 as the interior angle. So 140 is the sort of same interior angle for all of for our n-sided shape. Now, how could we work out what n is? Well, there's probably a couple ways you can do it. One, you can actually memorize a formula for this 900 and this 720 and this 450. It's 180, and then you do n minus 2. So that's the sum of the interior angles. And notice that if I take n equals 3, you get my first 180. If I take n as 4, then that leaves 2 here, 2 times 180. So you get the ones that we already know. And so since every angle on the inside is equal, this gives me a nice little formula for C in terms of n. Okay, so we got 140, and so then, expand out the top. Okay, bring the 140n to the other side, so 40n, bring the 360 over to the other side, divide by 40, and we'll get n is 9. So it's a 9-sided shape. Okay, so most of that was a verbal explanation. I mean, I did show my work there. Most of it's a verbal explanation because this is a light bulb. And they just want the value of n. So, you don't have to do anything. Just write 9 in the little box provided in the booklet. Now, we will have to write a bit more carefully our answer here to B. So, we got a trapezoid ABCD. BC is parallel to AD. They've shown that with the little notched arrows. Okay. And BC is perpendicular to AB. We got a nice little right angle down there. Also, the lengths AD, AB, and BC, in that order, form a geometric sequence. Ooh. Okay. Prove that AC is perpendicular to BD. So we want to show that these lines here are perpendicular. So what's a good approach to that? What's the best way to show lines are perpendicular? Now, we've got some geometry here. Could we think of a geometric construction? You might be able to. And if somebody's got a geometric, it's like a purely geometric way to handle this one, I would love to hear it in the comments down below. But I think probably the easiest thing to do, especially with that 90-degree down here, I think it's probably easier just to put these on coordinate axes. So, we should probably explain that. So, place B at the origin, A along the y-axis, and D along the x-axis. Oh no, it's BD, it's C. C is over here. Right? Yes. Okay. And then they told us we've got a geometric sequence. Now, the way geometric sequences work, and if you're not familiar with them, they do bother to explain it down here. Basically, the way a geometric sequence works is you start with one term. Typically, the first term is called A. And then you get every other term afterwards by multiplying by a common ratio, typically called R. So if A is the first term in my sequence, the next term would be A times R. Then we multiply that by R, so we get AR squared, AR cubed, and so on. Okay? Geometric sequences certainly come up a lot on contests, so do arithmetic sequences, which are the same sort of thing, except you add on the same amount to get between the terms. Okay? So they're a good thing to know for contests. Okay? So they gave us a particular order for these sides. What was it? AD, AB, BC. So let AD be A, AB be AR, and BC be AR squared. Or I'll just say suitable A and R. Okay. We know this can happen because it's a geometric sequence. I don't think you need to mention it, but here's our reasoning why. So we can definitely do that because it's a geometric sequence. So this gives us coordinates. So AD is A, AR, and AR squared. And this introduces coordinates. The whole reason I wanted to put this on X and Y axes in the first place is because it's really not that hard to show that two lines with analytic geometry are perpendicular, because their slopes just need to be negative reciprocals. Okay? So it doesn't have to be purely geometric. We can use our y equals mx plus b knowledge. Okay? So then b is at 0, 0. We said that from the start. A is AR above that. D, you go out by A, so it'll be A, AR. And C is at 0, AR. Oh, no, wrong order. AR squared 0. Because it's along the x-axis. Okay? So let's compute slopes so that people who are reading this know what I'm trying to do. Slopes AC and BD. How do you do slopes? Rise over run. So redraw our picture here just briefly. So AAR squared, no, AAR, 0 AR, 0, 0, and AR squared 0. So the slope of AC, rise, so I guess 0 minus AR over run. Just want to make sure that you keep everything lined up. So you make sure, I didn't want to get the order here wrong and do 0 minus AR squared on the bottom. So that'll be negative AR over AR squared. Cancel out the A, cancel out one of the R's. I'll get negative 1 over R. Now, I expect the slope of BD, this line here, to be R. So rise over run is just going to be AR over A, and it is R. So since the slope of AC is the negative reciprocal of the slope of BD, we conclude AC is perpendicular to BD, and that's what we were asked to show. Okay? So as I say, I'm interested if you have just sort of a nice geometric way, or a geometry way to sort of do this. But I think really it's just asking for an x and y axes, and the way we sort of see that, they're asking me to show that two lines are perpendicular. I know a real nice quick way to do that with coordinate geometry, and with this little right angle here, it's basically screaming, make me some axes. Okay? So there's question number 6. Up next, we're going to take a look at question number 7, and I will see you for that next time.